Hello ib1 students, welcome. Next lesson about thermal physics. So this lesson is for ib1 standard and higher level. We are talking about thermal physics. Okay, so this movie will be short because as you know, we will finish chapter. We finished this topic, and the idea is that you have to calculate some exam questions and I have to check your calculations as usually. Okay, do you remember after each chapter we were calculating, you were calculating, I was checking, so let's keep this scheme at this certain moment. Okay, but at the beginning let's check your homework. The exercise you had to do was exercise number 13 from page number 12 to the power of 2, so Tsokos page number 144, exercise number 13. It was your homework. Thank you, because most of you sent me answers. In most of cases, answers were correct. So now please open your answers for this exercise, and let's check with me. I'm going to give you a way. Of course, I'm talking about people who didn't do this correctly, and of course about people who want to check, people who are not sure. Okay, so the graph shows the variation with time of speed of object of mass 8 kilograms that has been dropped from rest from a certain height. So let's analyze graph at the beginning. Okay, so the speed on the vertical axis is given in meters per second. It starts at 0 and goes up to around 18 meters per second, and time is 12 seconds. And graph is a curve. It's not a straight line, which means that at the beginning speed increases faster than at the end, and object finally reaches a terminal velocity or something similar to terminal velocity. The speed is expressed in meters per second, time is expressed in seconds, and the body hits the ground 12 seconds later, so here, and the specific heat capacity of the object is 320 joules per kilogram per Kelvin. And you have in general 4 questions. You can obtain 4, 2, 2 and 2, so together 10 points for all of the questions. So examination time is around 15 minutes to answer all the questions. Okay, so let's focus on exercise number AI. Explain how may be deduced that there must be a resistance forces acting on the object. So let's look. Normally, object should accelerate with acceleration equals to g, okay, if there is no air resistance. Okay, so in this case, you see that acceleration is not constant. Okay, object changes acceleration because gradient of velocity versus time graph, which represents acceleration, changes. Is that clear? So acceleration of the object, which is gradient of this curve, decreases in time, which means that acceleration of the object decreases, and the decrease in acceleration means that there must be a resistive force. Okay, and this is the answer for first question. You have to refer to the gradient, and which is acceleration, and existence of resistive force. Okay, second, A2. Estimate the height from which object was dropped. Okay, I hope that you remember that when you have velocity versus time graph, then distance traveled by the object is represented by area under the graph. So you have to count squares, and by estimation you have to find area. What is important here? Each huge square has an area of huge square of 2 seconds times 5 meters per second. So each huge square represents distance which is equivalent of 10 meters. So you can find distance traveled by the object, so height from which object is released, by counting squares, and each huge square represents 10 meters. Okay. A3. Calculate the speed object would have had if there were no air resistance forces. Of course, speed, if there is no air resistance forces, can be calculated by using conservation of energy. If there is no air resistance, then potential energy of the object, mgh, is equal to kinetic energy of the object, mv squared. Okay, so speed is given by the square root of 2gh, where g is a distance traveled by the object, so height from which object is released, which was calculated in A2. So remember, height is distance traveled by the object in this case. Is it clear? Okay, and finally B. Estimate the change in temperature of the body from the instant it was dropped to just before impact. List any assumptions you made. Of course, you can calculate, and the red one, I'm going to use red color. Okay, so let's look. You have a real distance traveled by the object from A to. Okay, from real distance, you can calculate kinetic energy of, potential energy of the object related with the point from which object is released. Okay, so if you have a distance, you can calculate potential energy of the object because mass is given, mass is 8 kilograms. And then, by using a speed which object hits the ground, which is around 18 meters per second, real speed which object hits the ground, you can calculate kinetic energy of collision by using equation half of mv squared. So initial energy, potential, which is mgh, in the case of absence of air resistance, should be converted at all into kinetic energy. Okay, so it will be that potential energy here is bigger than kinetic energy. Okay, so the difference is heat, which is released or which is created when object falls. Law of conservation of energy says that potential energy of the object is the sum of kinetic energy related with collision with the ground plus heat which was created when object falls down. Okay, so by using this you can calculate heat, which is difference between potential energy and kinetic energy. Remember, potential energy is related with real height and kinetic energy is related with this speed of collision, and by using specific heat capacity, which is given, specific heat capacity, you can calculate change of temperature of the object. Okay, because Q given by using this equation, specific heat capacity given here, mass of the object is given here. There is only one unknown in this exercise, change of temperature. Okay, what is assumption made here? That all energy which is lost, so the difference between potential and kinetic energy, was converted into heat which was delivered to the object, not to the object and air which is surrounding the object, but only to the object. Okay, I hope that your solutions are correct and now you have no more questions. Okay, so what is next? I've prepared a kind of paper containing exercises related with thermal physics. Okay, exercises are in the form of open questions, not multiple choice, just open questions. You can correct a little bit more than 30 points, probably 31, or I don't remember, 32 points. So an examination time for this is around 50 minutes. Okay, at the time you're watching this movie, so due to our schedule, of course, I don't know what time you watch this movie. You have to watch this movie during our class. So at the time of our class at Wednesday, yes, you can find in Google Classroom a file containing a few questions related with thermal physics. A file is in PDF form. The best is to print it. If you are not able to print it, then use a kind of editor, I don't know, maybe Acrobat Reader editor, something you can put the comment to your PDF, or you can use software and you can write on a PDF file. Yes, in Acrobat Reader you can also write in Acrobat Reader you can also write in PDF file. So you have 50 minutes. Yes, you have to download this. You can get this, download this file. The best you have to print it, or if you are able to work with PDF, you can open it on your computers, tablets, whatever you have. Okay, turn on your watch. Yes, you have 50 minutes to solve all questions which are included to this paper. And then after 50 minutes, and maybe now all depends on the time you want to solve these problems, again you have to solve it in our scheduled time in our class. So you can also find the file with answers, but my request is don't open file with answers for you will finish to solve these questions. So the task is download file with questions. You have 50 minutes. This is your school time. You must do this. Yes, this is your typical school time schedule. Please solve this. Spend not more than 50 minutes. After 50 minutes you have to finish. Okay, if you will not finish your exercise, please stop, solve this after 50 minutes, and then open PDF with answers and compare your answers with answers in this PDF which are correct. Try to mark and send me your results. Okay, I trust you. I trust that your marking will be correct, and if you still have some problems, if you still don't understand some exercises, yes, please write this as a post in this topic in the Google Classroom, of course, not on YouTube, in Google Classroom. Write a post in Google Classroom with your questions, and of course I will answer. If it will be too difficult to answer by a post, of course I will record a next movie with exact solutions of all problems. I hope you understand this. So now please stop video. You have 50 minutes to solve questions which are in attached file called Thermal Physics Exercises. Yes? Okay, so thank you for watching. Have a nice day. Have a nice exercises. Again, if you will have problems, describe your problems in the post, then I will record movie with answers and with exact solution for the problems. Yes? So again, thank you for watching. If you have any questions, suggestions, please write to me. So learn physics, stay at home, and not see you next time, because next week I'm going to generate some grades. So you have to expect some test. I don't know the form, probably in the form of the quiz, but still I'm not sure. I'll inform you in this week. Okay, so good luck, learn physics, stay at home, and see you next time. Bye.